All right. All right. Well, welcome everyone to the latest Trees Around the Globe student research campaign. My name is Brian Campbell. I'm the lead for the campaign. And today we are continuing the science part of year 3 of the campaign. And today we're going to be talking about the lungs of the earth, the carbon cycle, and the science involved with it. And featuring Dr. Erica Podest from the Jet Propulsion Laboratory in California in the United States. So before we get to the feature presentation, we're going to cover some things, and I want to showcase you this time what the agenda is going to be for today. I'm going to do this brief introduction like I do at the beginning of every one of the webinars, and then we're going to have Dr. Christopher Schumann talk about trees in the news and about Norway Fund's satellite map of world's tropical forest and from Planet Labs. And there's a really cool Amazon, well, I shouldn't say cool, there is an Amazon deforestation video that really shows how it's been deforested over time, a super important, vital area to our environment. And, Amazon rainforest is one of those places that is so vital for, our Earth's carbon budget. So Christopher is going to talk about that after the introduction. And then we will introduce, Peter Falcon will introduce our featured speaker, Dr. Erica Podest. And then after that, we will have some time for question and answer about the presentation that you just learned about, anything that you want to know more about, any questions you have related to the science involved with the carbon cycle that Dr. Podest will be talking about. And then we'll bring on Dorian. She's going to continue her discussion on story mapping and show you some really cool stuff that she's been doing between the last webinar and now. And then we'll pass it over to our famous Peter Nelson and talk about online tools and data. He'll be showcasing some online tools for you. And then we'll finish up with some final Q&A and any discussion that we have. And then a little info about like the next webinar. So here's our core campaign team. I show this every time, but all of us are here in the webinar right now. So in the chat, if you have questions, if you want to direct it to any of us, just put our name in the chat and just say, you have a question for us. If you want to contact with us, we can put our emails in the chat as well. But feel free to post questions in the chat during the webinar today. And if you don't want to say, during the question and answer session, if you don't want to specifically come out and unmute your microphone, please put your question in the chat, and we will go over it. Peter will be going over the questions, and then we will be focusing on the answers, to your questions. So quickly, I always say quickly, but here we have the metrics now. I bring this up every time because we have lots of stuff going on with the campaign. We have lots of measurements coming in, and we had a big jump since last time. As you can see here, we have a lot coming in. We have this, here's a year 3 is what's happening now. It's only been since September 1st up until today, November 11th, and we've had over 3,700 tree height measurements come in from 1,624 global sites. And we have over 1,100 land cover measurements and over 1,900 green up, green down measurements. And I'm going to go out on a limb here and say the majority of those, if not 99.99% of those green up, green down measurements are coming from our awesome friends in Europe as part of the European Phenology campaign, because they do such amazing stuff, and you need to check it out. Go to the Globe website, look up the European Phenology campaign, and become part of it. Even if you're not in Europe, you can become part of this campaign, and they'll be happy to talk to you about it. It's amazing stuff. And right now, in the Northern Hemisphere, they're looking at green down, Southern Hemisphere green up. So since the European Phenology campaign, they're focusing on the green down right now because it's fall. So there's lots of amazing observations coming in, tree identification, leaf color identification, all these things are coming in from the European Phenology campaign and adding to the green up, green down measurements. So we have over 55,000 measurements that we can attribute to the length of the campaign since September 15, 2018, up to today. Just this morning, I did a data count. So that's what we have as of this morning, over 55,000 data points combining the trees, land cover, greenies, and carbon cycle. Carbon cycle one is really low. It's a pretty complicated protocol to do, and there's different ways you can do that protocol. But I suggest taking a look at it, and once you figure out, what to do, there's trainings on it, online tutorials, there's videos, so you can learn all about how to do it. So it's a really cool, really important protocol, or Global and have it in their database for data collection. So go check it out. But yeah, so we have lots of stuff going on. We have all the recorded webinars. We have participants from over 52 countries right now. And right now there's 37 blogs that are related to the campaign, and we're closing in on almost 100,000 views from these 37 blogs. So lots of good stuff. So go check it out. Just go to the Globe go to the Trees Around the Globe Student Research Campaign website on the Globe page at www.globe.gov. And you can go under the Do Globe and search for measurement campaigns, and the trees one will pop up at the top. So as I mentioned earlier, we're in the last part, coming into the last part, I should say, of the first quarter of our campaign. We are focusing today on the carbon cycle science, and then next month we're going to focus. Peter Nelson will be our featured speaker, and that'll be December 8th, and I'll be sending that notice out soon. It's on the website, on the webinar page, but you can check it out. We're focusing on that science, and then next quarter, starting in January, we'll be focusing on how students can take the science they just learned about in the first quarter of year 3 of the campaign and focus on how to plan student research and how to start the student research, how to go through, that the overarching question and all that. So here we create a little section here on the page, okay, submitting your student research. If you're ready to submit, I put a link on here, and you can go to this bit.ly down here at the bottom and see this exact stuff. But if you're ready to submit it, you can go to the 2021 Globe IVSS page and learn more about what you need to do to submit it. If you're having any questions or problems, or you want help from the campaign, from the campaign team, or if we can put you in touch with someone else you may want to work with from another country, if you're in the US, another state, or anywhere around in the Globe community that are part of the campaign, feel free to send an email to Peter Falcon or me, and you can click on our names on this website. If you go to this bit.ly on the campaign website, and it'll send us an email directly. It'll open up whatever your email browser thing is, and then it'll pop up, and you can send an email requesting some assistance in the campaign. So with that, I will pass it over to Dr. Christopher Schumann, and he will talk about trees in the news.
Thanks, Brian. This is a segment that we added within the year, in part because of the growing recognition of the importance of trees around the globe, and all of the different ways that people are sort of getting a better understanding of their importance. So a lot of news stories, including sad news like trees dying off, but also kind of really interesting, fun news like France's new national park, which we did in the last webinar. This time, there's some new science studies that are trying to understand how trees might help fight climate change. And so these links should be popping up in the chat, so you can read these stories in full for yourself. But basically, this is highlighting the importance of how trees take carbon from the atmosphere and store it in wood and soil. And many entities around the world are embracing tree planting efforts to fight climate change. So this is great news, pledging to restore forests over a large part of the globe. Some plans include, conservation or restoring, hundreds of millions of trees in the next decade. This is really kind of exciting. So scientists have kind of set out to understand, that yes, we know that new trees and forests can help cool the planet, but how effective are these efforts to implement forest-based solutions? So the science has gone and tried to measure, and quantify how well these efforts are working. So 2 papers have come out this week, published in Science magazine. And one study quantifies how much carbon might be absorbed globally by allowing forests cleared for farming or other purposes to regrow. And the other study calculates how much carbon could be pulled out of the atmosphere and sequestered by forests in just the United States if they were fully stocked with newly planted trees. And their summary is each strategy has promise, but they also face perils. A colleague of mine at UMBC, Matt Fagan, I didn't know he was going to be quoted when I found this article, but Matt's a good guy, so I had to grab a quote here for him. Natural regrowth is not going to save the planet, unfortunately. The young forests are easier to cut down or burn than old ones. Is apparently one of the perils that this approach faces. But one of the researchers in one of the papers, the lead researcher, Susan Cook-Patton of the Nature Conservancy, says planting trees might make some sense in some places, but adding trees in fire-prone areas could increase fire risk for, well, for everybody, humans, animals, and other trees, especially as climate continues to warm. So it's important that this work is going on, but clearly we need to keep studying the subject as time goes forward. Next slide. So this was in another story that I found on bbc.com. Norway has basically awarded a very substantial sum of money to work with Earth observation specialists to access their imaging expertise, covering all the world's tropical forests. And you can see the area illustrated on this graphic that I pulled from the story, you know, covering Mexico all the way down most of South America, large portions of Africa, Madagascar, India, and Southeast Asia as well. So it's a huge investment to make these data freely available so that anybody can monitor and study how trees are faring in their area or across the whole region. So there's a number of links there where you can check this data out and read up more on who's contributing what to this effort. But again, an important illustration of how much we need to know about what's going on with the world's tropical forests and forests everywhere. This next slide is from the BBC story, and it basically illustrates the kinds of peril that these forested areas can be faced with. If we can get this to go, there we go. Basically, you'll see a good part of the past 5 years illustrated here with high resolution satellite data. Not during the rainy season. You'll notice there are gaps in the record, but you'll see roads go into forested areas, and then basically the underlying story is once the roads go in, the trees come out. And this area of the Amazon rainforest, kind of north of the Bolivian border, is just being, well, logged extensively just in the past few years. And so probably the initial benefit is the trees themselves for whoever's doing the logging, but then the land becomes exposed for farming and potentially erosion of its what used to be forested soils during the rainy season. So there's a lot of consequences illustrated in just this few years of planet data. But I think it's a kind of striking illustration of how much impact deforestation can have in what was an extensively forested area in this part of the Amazon. So that just brings home I think the underlying part of the story, which is we're all in this together. And even though you and I may never get to the Amazon, what's happening there is going to impact us here. So just an illustration of the kind of data that Planet is able to put out from its constellation of small sats that are orbiting us right now and producing amazing imagery and enabling us to see what's going on in places that we certainly nowadays would have no chance of traveling to do on the ground measurements. So kind of one of the underlying things about NASA is being able to see places around the Earth and also through the solar system and elsewhere, and what's happening there with our remote sensing. Thanks, Brian. Let's jump ahead to the last slide. And another element of all this is there was a NOVA program, Can We Cool the Planet, featuring one of the researchers that we know from NASA Goddard. And if we're lucky, we can play the promo for this. And again, the links should be in the chat, and you should be able to play this full episode when you've got time to sit through the extended cut, if you will. And let's see.
It's thinking.
Yes.
There we go.
There we go. The internet can be a little slower than we'd like.
Rising temperatures.
We need to reduce the heating effect.
Can we stop them?
Every year, the damages are worse.
From going too far. Now, help may be on the horizon.
It's going to be revolutionary.
New technologies that could turn down the thermostat.
It's like science fiction.
But are they enough? Can we cool the planet on Nova?
So some of the things that were discussed there were
This month in Passport.
Ground and space-based measurements of trees, including the JEDI instrument on the International Space Station. And so it just, again, highlights the importance of studying trees around the globe. So with that, I'll pass it back to Brian, and thanks for your attention.
All right, so now we're going to go into our featured talk, and I will pass it over to Peter Falcon for an introduction of our featured speaker.
Let me just admit one more person. There we go. Thank you, Brian. Thank you, Chris. I just want to start off by saying if anyone has any questions at any time for any of our speakers, please feel free to put them in the chat box, and we will monitor that and ask the speakers those questions. It is my privilege and an honor to really introduce the next speaker. She's somebody I've known for quite some time. It's that scientist that you work with a lot of times, Brian, where you forget to call them doctor, you just know them by their first name.
Right.
That's how I know Erica, or Dr. Prades. Anytime I need something from an outreach or educational perspective, she's always there for us. She's always there for students and teachers. So it is somebody I really enjoy working with. Dr. Prades is going to be doing a presentation today entitled Trees, the Lungs of the Earth. And she is a researcher at NASA's Jet Propulsion Laboratory. And she's going to be talking about carbon cycle and the eco-stress group that she works at. And she'll be also talking about, I met that person as well, the roles trees play in the carbon cycle, and about satellite technology as well. We use satellites to talk about how we use satellites to study our planet. So with that, I'm going to go ahead and turn it over to Dr. Erica Prades. And as I mentioned, if you want to know more about Dr. Prades, we actually have an interview of her on our website. So you can go there and find out more about her research, her interests, and how she works with a lot of students, not just in the US, but in Latin American countries as a whole. So with that, I'd like to turn it over to Dr. Erica Prades.
Thank you very much for that kind introduction, Peter. And thank you everyone for tuning in. As Peter mentioned, I'm a scientist at JPL. I've been a scientist there for about 11 years, and I work in the carbon cycle and ecosystems group. So the focus of my research is the study of terrestrial ecosystems using satellite images, and I specifically use sensors called microwave sensors, and I studied two types of ecosystems: wetland ecosystems and boreal ecosystems. So I study the vegetation in the northern high latitudes and how a changing climate is having an impact on these ecosystems. So today I'll be focusing on trees, the lungs of the earth. And really when I talk about trees, I'm also referring to vegetation. So I'll talk about the carbon cycle and how the contribution of trees in the carbon cycle, and then how we're observing the carbon cycle from space, and specifically the contribution of trees and vegetation. So let me start out with explaining the carbon cycle. So it's a cycle, right? So carbon is the building block of life. We are made up of carbon. Animals, plants are made up of carbon. And this carbon is stored in different reservoirs around our planet, in the ocean. And actually the ocean is the largest reservoir of carbon. It's stored on land and on trees and in the soil, and it's in rocks, and it's stored also in the atmosphere. And so the arrows that you're seeing here, the purple arrows indicate that carbon is being taken up, and the yellow arrows indicate that carbon is being released. So it's a cycle. It's always the same carbon in the planet. It's just being cycled around these different reservoirs. And on land specifically, plants remove carbon from the atmosphere through a process called photosynthesis. And I'll talk more about this in the next slide. So when animals eat plants and either breathe out the carbon, or this carbon is moved up the food chain. And also when animals and plants die and decay, that carbon is transferred into the soil. So what's happening in our planet is that we are taking these large reservoirs of stored carbon, and we're releasing that into the atmosphere through burning of fossil fuels. And we're doing this, or we've been doing this, in a very short period of time. So it's taken hundreds of thousands of millions of years for these large reservoirs to form, and we're releasing those in a very short period of time. So this is a bit of an issue, right? So usually the carbon cycle is in balance. You know, what's released into the atmosphere is kind of taken up by the ocean and what's on land, but usually it's in balance, but we have been tipping that balance by taking the stored carbon and releasing it into the atmosphere. So what is specifically the role of trees? You know, you saw that there are these reservoirs, but really what's the process of taking up that carbon and storing it? So trees are part of that process. And as I mentioned, through photosynthesis, what they do is they use the sun's energy and they convert carbon dioxide into oxygen and carbohydrates, starch. And then that starch is used for the plant growth, and part of it is stored in the plant itself, and that's known as biomass. So it's carbon mass, and that's stored in the trunk, it's stored in the leaves, in the stems, and the branches. So it's a very fundamental process for life on Earth, photosynthesis, taking the sun's energy, carbon dioxide, together with water to produce oxygen and starches. And then this carbon is not only stored in the plant itself, in the roots as well, but part of it is in the soil. Also, as a tree loses its leaves, those leaves, their carbon mass, they decompose and they're part of the soil. So very important process and very critical to life on Earth. And that's why we tend to call, or it's a great metaphor to talk about trees and vegetation in general as the lungs of the planet. They're taking up CO2 from the atmosphere, and they're converting that to, they're storing it in their in their structure, and they're producing oxygen. Very important. Also, the one thing about trees is that as they grow, they're taking up more CO2 from the atmosphere than when they're mature. So it kind of tapers off that uptake of CO2 throughout the life of a tree. And this is an animation. Let me just play this. Kind of this carbon cycle or this life of a tree on land. Okay, so it takes up CO2. You've got the trees. This is in spring. It'll grow out the leaves, and those leaves will fall in the fall. And those leaves and stems or branches that fall become part of the soil. They decompose, right? And so there's this whole life cycle in the trees. Eventually they die and they either decompose and become part of the soil, or sometimes they burn, and that carbon biomass is just released directly into the atmosphere. So actually fires is a very direct way to increase CO2 concentrations in the atmosphere. That carbon that's stored in the trees is released directly into the atmosphere very quickly. So we observe these processes by means of satellites, and NASA has a whole fleet of satellites to observe many different aspects of the Earth's environment related to the oceans, the atmosphere, and the continents, terrestrial ecosystems. And together they provide this big picture perspective of our Earth as a system. And so some satellites are measuring part of the hydrology cycle, carbon cycle, energy, different aspects. But you've got satellites that are measuring CO2 concentrations in the atmosphere. You've got satellites measuring tree greening and tree health, evapotranspiration from vegetation, satellites that are measuring the amount of water in the soil so that trees can grow. So different components that affect this, the carbon cycle, both on ocean and on land. On ocean, you've got ocean color, and you've got plankton, which is the equivalent of vegetation in the ocean, and they take up CO2 and produce oxygen too. So as you all know, the greenhouse effect, so the CO2, carbon dioxide, is a natural gas found on Earth. It's a greenhouse gas. The greenhouse effect is a natural effect on planet Earth. And thanks to this greenhouse effect, we can live comfortably in this planet. It's an average of 15 degrees Celsius. Otherwise, it probably would be too cold for us to live here. And so what's happening with the greenhouse effect, it's being perturbed. We're increasing the concentration of some of these greenhouse gases, including CO2, which is the most important man-made the most important greenhouse gas that humans are having an impact and a direct effect on. And so that's really what we're following here is CO2. We're really trying to understand what are the concentrations of CO2 and what are the roles of the different components of our Earth's environment in terms of taking up and releasing CO2. Okay, so one of the things that NASA does is it measures atmospheric CO2 concentrations from space. And I will show you a video animation of atmospheric CO2 concentrations starting in June 2003, and I think this goes through the end of 2006. And the bluer, the lighter colors, the blue, gray, are lower concentrations of atmospheric CO2, and then the yellows, reds are higher concentrations. So these are parts per million. And as you can see, as we go through time, these are average monthly atmospheric CO2 concentrations. As we go through the years, the months and the years, you'll see a gradual shift towards higher concentrations of atmospheric CO2. So it started out with the grays and the light blues, and it progresses to yellows and reds. So let me just put that into perspective. This is a graph. This is actually CO2 concentrations measured in Mauna Loa Observatory in Hawaii. And throughout this time period, that's what it looks like. So there are two things to note here. One is that atmospheric CO2 concentrations have been increasing. But another thing that some of you might notice is that there's this cycle, right? And you might be wondering, what is this cycle? What is driving this cycle? And really what that is the vegetation up in, primarily in the northern high latitudes. This vegetation is seasonal. So in the winter, vegetation, there's really a noise change of the CO2 between the vegetation and the atmosphere. So it kind of hibernates. And so during this period of time when the vegetation freezes or hibernates, then during this period of time, atmospheric CO2 concentrations globally increase. And that's why you're seeing that it's that seasonal increase and decrease. So to put this all in perspective, in terms of atmospheric CO2 concentrations, currently we're at 415 parts per million. And if you look back at the historic record, really in the last hundreds of thousands of years, it hasn't gone up past 300 parts per million. So these are unprecedented times. And what can we do? What can vegetation do to help us? So let's understand the problem a little more. The northern high latitudes are considered ground zero for climate change. And the reason for this is because these areas have a strong seasonality, and the temperature increase in those areas has been twice to 3 times as fast as the rest of the planet. These areas, during the winter, there's a lot of snow. In the Arctic, there's floating ice. And so all of these areas that are white reflect the sun's energy back to space. So this seasonality where you have snow, it just reflects a lot of the earth, the sunlight back. However, these white patches, what's called the albedo effect, is being lost. So there's less snow cover. You've got darker areas. Exposed water is darker than obviously ice, and on land also you've got areas where you've got patches. You don't have this as much snow as you used to have. So those dark areas that are exposed tend to absorb more heat. And so overall, this area is warming faster than the rest of the planet. And so this has a big impact on the global carbon cycle, right? Because if this area warms, this is a tricky question now. The vegetation, as you saw, plays a large role. So what are the implications of a warming planet on the vegetation in the northern high latitudes? So the implications are that you might think theoretically it's a great thing, because as things warm, the growing season, that's the period of time when the vegetation grows. So that starts around spring and it goes through fall. So you've got sunlight, you've got liquid water, and you've got temperature. Obviously that's above 0 degrees. And during this period of time, you've got vegetation growing, taking up CO2 from the atmosphere. And these are millions and millions of hectares. So you'd think that with increasing temperatures and longer growing season, which is what we're seeing, it's better that the vegetation will take up more CO2 from the atmosphere, but we're actually not seeing that, because in practice, what's happening is that the vegetation is becoming water stressed. There is overall, the snowpacks are thinner, And so there's less water availability. So at the end of the summer, the ground is becoming just very dry and vegetation is becoming water stressed, and it just stops taking up CO2. It just goes into shock, let's put it that way. And then also another phenomenon that we're seeing is that more and more there are these days, just continuous days of just really high temperatures up there, up in the Alaska area where I do a lot of my field work. And the vegetation there is kind of cold weather adapted. They're not really used to like these continuous days, just a week long of extreme temperatures, high temperatures. And so what happens is they become stressed and they shut down. So there are other things too. There are, because you have a longer growing season, you've got more opportunities for things like the bark beetle. You've got the bark beetle infestations and diseases attacking the vegetation. So you've got basically the bark beetle. Under normal conditions, it just had one reproductive cycle during the growing season, but now with a longer growing season and just better conditions for them to survive, they have two reproductive cycles, so they have more time to really have an impact on the vegetation. So the vegetation is weakened, and then you've got the next season, they're already weak and they get hit again by these infestations, and you have these massive die-offs. Okay, and that has overall an impact. Anytime you have trees that are dying, you're eliminating that possibility of that tree taking up CO2. And obviously when the tree decomposes, it's that carbon mass, part of that carbon mass is going up to the atmosphere. Part of it stays in the soil. If it burns, obviously most of it is going up into the atmosphere. This is a really cool video animation that shows, it shows the greening of it shows a seasonal cycle of vegetation and the concentration of carbon dioxide in the atmosphere. So the green that you see on land is kind of that seasonal cycle of vegetation. In some areas, you've got wet seasons, dry seasons. Take a look at Africa. You've got this greening that's going up in the northern edge of Africa. It's quite extraordinary. And so in the northern high latitudes, you've got during the spring and the summer, you've got the vegetation greening. And during this period of time is when you see this huge uptake of atmospheric CO2, which is represented in yellow in this animation. Okay. So that blooming effect in the northern high latitudes causes an uptake of carbon dioxide. So there you go. Obviously, there's a bit of a lag, and you expect that, but you can clearly see, okay, so here, you've got an accumulation of CO2, you've got the greening in the northern high latitudes, and you've got that just enormous uptake of atmospheric CO2 afterwards. Pretty amazing, huh? All right, so I'll move on in the interest of time to the next slide. So another thing that we monitor from space are fires, and how is this changing, and what is the impact of fires in the global carbon cycle? You know, so fires are natural in many places. In other places, they're deliberately done to clear land for either agriculture or for grazing. And so we can see by means of satellites fires, and if we have a long enough database of fires, we can understand whether fires are increasing, what's the distribution, the extent of fires. And so you see a lot of fires in Africa. Africa is, it's kind of called the fire continent. There's just a bunch of fires going on there. A lot of them are, most of them are just, I believe they're natural fires. But it goes with the seasonality. So in the dry season, you'll have more fires, obviously, than in the wet season. And sometimes when you have drought years, 2015 was a very strong drought year. For example, in the Amazon, you see a larger amount of fires taking place. So what happens with fires, as mentioned, so that CO2 that's stored in trees is released into the atmosphere. You eliminate that ability of that tree to take up CO2. So it's got really strong implications in terms of the carbon cycle, and especially when it's at a large extent. And here is an animation that shows the transport of the carbon that's released during fires. And this is really an impressive animation. So the red, and by the way, this is model data. And so you see different flows of aerosols due to sea salt, due to dust. If you look at the Sahara, that's dust being picked up by wind currents, and then they're being transported to different parts of the world and also with the jet stream. And you can also see how fires generate these huge plumes of, they're primarily carbon monoxide. So carbon monoxide is an atom of carbon and an atom of oxygen. And once it's in the atmosphere, that molecule will, not necessarily always, but it'll find another atom of oxygen and create CO2. So whenever you have forest fires, you have this huge release of carbon monoxide, and that's what primarily you're seeing with these red plumes. And as you saw, another thing that we are monitoring from space is deforestation. And as you saw in the previous animation that was shown, it shows just the severity and how big of a environmental impact this has on the environment. I mean, these areas that are being deforested are huge, right? And they're being deforested for primarily grazing, at least in the Amazon. So this is an area that's about 60 kilometers by 60 kilometers. And during that period of time in this animation, it's been mostly deforested. Okay, so before I close, I just wanted to say that we have these different ways of monitoring vegetation in our planet, and different components of vegetation, whether it's healthy, whether it's being deforested, and what happens when that vegetation is either cut down, or what happens when that vegetation is burned. What are the implications of that to the CO2 in the atmosphere? There are global accords to try to protect forests for their value. So rather than cutting them down for different reasons, protect them and have that hold a larger value than cutting them down. And a very important accord is called the REDD. So that stands for Reducing Emissions from Deforestation and Forest Degradation. Very important word here is degradation. So it's not only about deforestation, but also there are many degraded forests. And those aren't really being taken into account. So there are millions of hectares of forest that are degraded because either they're sick or there's also selective logging. So when you pull out a tree, just because it's a specific type of tree, it might damage trees around them. So there's a lot of the forests that are standing, but they're degraded and they're not taking up CO2 the way that a healthy forest would. So these are being taken into account under this REDD activity. So with that, I close, but I just wanted to add something else. I've talked about forests being, or trees being the lungs of the planet. But, you know, as I was putting this presentation together, there's so much more than just the lungs of our planet. They're really the intestines of our planet. They transfer nutrients. They're the skin of our planet. You know, they transpire. They modulate temperature. They are the heart of our planet. They're just these places where you have these huge amounts of flora and fauna and biodiversity. So they play a very large role in, I think, not only the health of our planet, but obviously our health too. So with that, I'm open to your questions. Thank you very much.
Thank you, Dr. Podesta. I was going to say Erica. Thank you, Dr. Podesta, for the wonderful presentation. We do have a few questions in the chat box that I'd like to address with you. The first one comes from, let me look for it, comes from our colleague from Pakistan, Bushra. So I just want to point out, she has been up, it's 1 a.m. over there, so no pressure about her question at all. So she's wondering, what are some of the indicators for the carbon cycle balance? You mentioned the carbon cycle and its balance, and she's just wondering, what are some of those indicators for that?
What are some of the indicators for the carbon cycle imbalance? Is just the constant increase in atmospheric CO2 concentrations that we're seeing.
Okay, thank you. We have another question for you. This one is in regards to the US's western states fires that we recently had. The question is, it's here. The question is there a way to measure the amount of carbon that was released in the atmosphere from the trees and forests that were burned down during the recent wildfires in the western part of the US?
Yes, there are. I'm not specifically involved in that study, but I do have colleagues that are already assessing like the number of trees that were burned down, their potential biomass, and so how much was released or how much biomass was lost and carbon released into the atmosphere.
Thank you. Another question from a colleague, Brian, is do falling leaves from trees affect the carbon in the soil?
Yeah, absolutely. So the falling leaves from the trees, they decompose and they become part of the soil. And same way when a tree dies, it decomposes and part of that becomes part of the soil too. One thing I didn't quite mention, the soils are really important. I mean, they are very large reservoirs of carbon. And the soils, they go through a process called respiration. And so they store carbon. They also release some carbon. And in the northern high latitudes, this is soils play a really critical role because you've got this vegetation that kind of dies and it just gets frozen. The growing season is so small, and up in the tundra, you've got just a couple of months of a relatively short period of time when temperature is above 0 degrees. And so during this period, you've got vegetation growth and death. And so you don't have really enough time for this dead vegetation to decompose. It just kind of gets frozen and it's just built there year after year. It just gets frozen. That's what permafrost soils are. These frozen soils that they've been frozen for hundreds, thousands of years. Some are just a couple of centimeters in depth. Others are meters and tens of meters in depth. And so these soils store so much carbon. It's estimated that they store twice as much carbon as what's in the atmosphere. And the concern is that as temperatures increase, these soils thaw and they release that stored carbon into the atmosphere.
Thank you. Another question is, you mentioned that trees convert carbon dioxide. Do all trees convert it the same amount, or is there different levels of conversion from those trees?
trees, can you say that again, please?
Sure. So trees convert to carbon dioxide, I think you mentioned. Is there, do they do it the same amount? All trees convert the same amount, same level, or do they do a different percentage of carbon dioxide?
No, it varies by the type of tree. It also varies on the condition, the health of the tree. And also it depends on the stage of growth of the tree. I think I mentioned this during my talk that initially when a tree starts to grow, it absorbs more CO2 than when a tree reaches maturity. I mean, I think it's like people, you know, it's like, you know, first 10, 15 years of our lives, we grow and then we stop really growing. And so the same thing with trees. Yeah.
Another thing that we seem to talk about when we talk about the carbon cycle are these terms, sinks and baths. Can you explain those?
Right, so you've got sinks and sources. Okay, so carbon sinks are areas or are ecosystems that take up more carbon than what they release. For example, wetland ecosystems, and these ecosystems I study quite a bit. So wetland ecosystems are ecosystems or vegetation that inundates periodically or seasonally. And there is, they tend to store a lot of carbon in their soils particularly. And so it's a fine balance. They also release carbon into the atmosphere, especially through methane, because there's a lot of anaerobic decomposition in these type of ecosystems. But over time, they are net carbon sinks rather than sources. So that's what a sink is. If something is a source, that means they are releasing more carbon than they are storing. The concern with wetlands is with increasing temperatures and changes in water availability, these ecosystems might become sources. They might be releasing more carbon into the atmosphere than what they're storing.
Thank you. We have another question from South Korea. This question is, how does the greening down affect the carbon cycle? Does it contribute to global warming? I guess, so that would be the question.
Right, so I'm assuming that the greening down here is related to just the natural greening down due to the seasonality in the northern high latitudes. So during this period of time, this is natural and this happens, you know, seasonally. During the greening down, there is a accumulation of carbon, of CO2 in the atmosphere because you're really temporarily eliminating that mechanism of taking up CO2 from the atmosphere. Does it contribute to global warming? The natural, it's a natural cycle, this greening down. So I think if I understand that question correctly, the cycle itself is not contributing to global warming.
Okay. One last question for you before we move on is, you mentioned in one of your slides, we're at 415 parts per million. Are we at a tipping point at this point? Can we realistically go back down to normal levels per se?
Yeah, that's a great question. I'm not sure I can answer that directly. I think the tipping points are really something that we're trying to understand and determine what are the tipping points for these different ecosystems, you know, kind of like what are the points of no return. But what I can say is that there's a lot of energy in our system, right? It's like you've got a car speeding down the road and you press on the brakes, or say a train speeding, and you put on the brakes, it's not going to stop immediately. So even if we stop CO2 emissions today, we'll still see a certain level of warming. It'll taper off much sooner, as if we were to continue with business as usual.
Okay, thank you very much, Dr. Bades, for your time. One last comment from a colleague regarding some of your animations. She said you really get the sense of the earth breathing in your animation. So thank you very much for spending time with us today. Thank you for answering our questions. And with that, I'm going to go ahead and turn it over to Brian.
Thank you
All
very
right.
much.
Yeah, thank you so much, Dr. Podes. That was wonderful, and a great discussion on the carbon cycle, which is such an important part of our campaign. And it's just one of the measurements that are being taken as a globe protocol as part of the campaign. But as you mentioned, the carbon cycle just fits within everything else that we do in the campaign, and everything, how our planet functions. It is such a, a vital variable, huge variable that's part of our planet, and understanding how our planet's responding to change over time. So thank you again. And with that, I'm going to pass it back to my, I'm going to go back to my PowerPoint, and we are going to pass it over to Dorian Janney, and she's going to discuss story mapping and what she's been doing over the last several months with the story mapping she's been doing, which is such a great tool for students to use as part of their research. So let me pass it over to her. I will stop sharing my screen. She will bring up hers then.
Thank you, Brian. So yeah, I have been having, whoops, moving this up here.
Mm-hmm.
Not right now, baby, not right now. Sorry, I'm trying to get my screen up. Sorry guys, I had it behind here and it's disappeared. Come back here. Give me one sec. Yeah, so I've been having a lot of fun learning how to do story maps. And I decided that because that is one of the ways that IVSS says that students can now be sharing their science projects, I thought, wouldn't that be a wonderful way for me to start to learn how to create these story maps, and then try to take the concepts that we're working with and the questions that we're working with, and using trees data, and find some ways to create story maps with that data. So let me just check and make sure you're seeing the story map now.
Looks good, Dorian.
All right, great. So let's go around the world with globe. So what I did is I started off by going to the globe visualization, and I looked at all of, and that's what we're seeing right over here with the tree height data. These were all of the data counts as of November 5th, 2020. So then the next thing I thought is, I want to look at some various places around the world and see how, look at the pictures of the trees and see how they differ. And then see if, based on how they differ and getting a little information like that, I might be able to come up with some questions that one could answer doing an online investigation. So I saw where the pictures were. And then it's always kind of nice to start off at home. So there's where I live, number 2. That's Damascus, Maryland. I'm about 254 meters above sea level. And so these pictures were taken on in October 2020. And I just thought that was kind of a good idea to show, to try to pick trees that were taken around the same time, or at least to note when these pictures were taken. Another thing I was thinking as I did this is I need to do my land cover data at the same time, and then have that data up there as well. So that's something I'm going to try. Another thing that I did is I had gotten the precipitation data from the GPM mission, which I work with. And this is showing how much precipitation has fallen over the last 20 years. And basically we're looking at that as in terms of how many inches were falling per month. Because I thought that would be a neat thing to look at as we're comparing and contrasting trees. So then I went down in Africa to Cape Town, where I knew that we had some pictures coming in. So here are some pictures of some trees in Cape Town. These were taken in June and July of this year, 2020, at a much lower elevation. And there we go. And that's where I would, as I looked at these trees, I was thinking, gosh, having those land cover observations to kind of compare and contrast and get a feel for what the vegetation was like would really be interesting, especially when I'm adding precipitation data as well. So then I moved from, sorry, but this baby has been quiet this whole time, and now she's deciding she's going to start singing and talking to us. So then I went up to Alaska, where I saw that there were some pictures. And what's really neat with this story map software is if you get the name, and by going over to the GlobeViz website, you can find out the name of the town where the data was taken from. And then you just look up the name of the town, and it will actually go and as we're seeing here, it will take you right to that place. So Story Maps has all kinds of really fun features. I've only just started to learn some of the neat things you can do with it. Well, here we are in September 2020 at about 121 meters elevation, and some kind of neat trees over there. We're looking at some coniferous trees. Okay, then I went down to Argentina, where I know that Ana Prieto and her team have been collecting all kinds of observations, and they shared with us earlier this year. And I took a look at some of the trees around there. Now, these data were from January 2020, and of course the seasons there are flipped, so that would be around their summertime. And in this case, we're looking at pretty high. They're way up there in the Andes Mountains. So we're way up high in elevation there. And so it's just interesting to take a look at the pictures that they have shared there with some of their trees. And then the last place that I wanted to take you to is in Georgia. Georgia, the country way over here. And it was really neat to hone in and find where these data were taken on the map, and then make sure that I could find it on this map. And so here we were looking again at these really neat coniferous trees and getting a feel for, kind of the barren landscape. Hey, you, hush, you're competing with me. That's over there in Georgia, at least in this part of Georgia. So what could you investigate? And here's my little granddaughter standing with a tree over at her house. Well, you could investigate why or why aren't there trees in my local environment? So we would like student participants to be focusing on some of these different questions. And then all of the data that I shared was using online tools, just going to Globe Data Viz and grabbing pictures that were up there other than the GPM data that I was showing you. And basically with that, you could look at things like, where are all the trees in your location? What is the tallest tree in your location? Because you can get the tree heights when you're looking at the data. What type of trees are around me? What are the environmental conditions around me? Maybe you're not seeing trees in your location, so why aren't you? Why do we have tall trees where we do in some places around the world? In areas with retreating glaciers, how soon will we get trees in that area? What are some of the succession processes that can cause trees to grow, and what things can interrupt with those processes? And then, a few more questions here. I'm not going to read all these to you, but they're on the front page of the Globe Trees Around the Globe campaign site. So I just wanted to show you that is kind of one down and dirty, interesting thing that you can do using story maps.
Thank you, Dorian. That's great. And I could tell your granddaughter was super excited about it all too. So that's awesome. We're good. We're all informal here. That's awesome. Yeah.
I hope you can hear over.
Yeah, all good. So yeah, well, thank you so much. As you can see what Dorian was talking about, this is such a great tool to use, the story map, to help you, paint the picture of what's happening in your local environment and keeping it all in one place, and, telling that story, hence the name story map, from when you started doing research, or when your students, or you as students, and we have some students on here today, when you start doing the research, and then you can keep this running, really cool chronological kind of a data port for all this information. So thank you so much, Dorian, for sharing that. And we'll continue with the story mapping each month during our webinars. So thank you for that. Right now, the last part of our campaign webinar. Before we go into the final Q&A, any discussion, I'm going to turn it over to Peter Nelson, and he's our campaign co-lead and expert in online tools and data analysis. So take it away, Peter.
Thanks, Brian. Yeah, I wanted to take the chance and give you guys some tools that you can actually use to explore the carbon cycle and biomass and some of the information that Dr. Podest was talking about today. And I know a lot of people were really excited and impressed by the breathing earth, right? And some things like that. And so I'm going to take us back to a tool that we've talked about before in our Trees Around the Globe webinars, and it's a great place to just start some interesting investigations to explore some patterns. And this is the NASA, the Worldview website. And here is a great place where you can actually see some of the smoke, some of the dust, some of the clouds, and track some of the breathing and dynamic Earth here on this website. Now, hopefully at this point, you've come to recognize some of the patterns of remote sensing data, where we have part of the Earth has been imaged and the other half hasn't. And so remember, we have to go back a day to actually see the last recent observation. But here, we can actually start to see some of the patterns and some of the colors that Dr. Podest was talking about. And depending on the time of year, you can actually zoom in on Africa here and watch that dust being transported off of the Sahara Desert, like she mentioned. And then, importantly, you can use this to track all kinds of interesting patterns. And so I am going to go back because this was something that was kind of brought up before. Is back in August we had these big wildfires in the western part of the United States. So as you can see, we can just zoom forward and look at the patterns at various points in time. And you can see I'm trying to kind of go forward to when we actually had some of those fires break out. And so here is an example of the carbon cycle in action. So here is Northern California, and here we're actually seeing those smoke plumes that is converting a forest similar to what's behind me into different chemical parts. Some of it's going to the atmosphere, some of it's getting burned up. So you can see the difference between smoke and the carbon cycle versus water on the coast here. And so what's really interesting about this is, you can look at particular events and watch the carbon cycle actually happen like that. The other thing that I'll point out that you can do is we can change this and look at monthly cycles. And so I'm actually going to just go back a little bit in time. Wow, there's another example of August, Northern California on fire. And so, but you can actually animate your own map by using this little button right here. And so you can change some different parameters, but we can go between August 2018 and let's go forward to August around the same time. So we have 2 years. So you can go through and you can actually, it will load the imagery and actually give you this sort of time series, similar to what Dr. Podest was showing. And so here we're just looking at what the satellite image sees from space. The nice thing is you can actually get different layers inside of here that might relate more towards the carbon cycle. Actually finding the fire, for instance, you can come in and you can turn on the thermal data and actually see some of those fires and make an animation similar to what she was showing. Here is the hot spots from that fire that we were just looking at. And so you could actually go through and create your own animation on a daily increment, a monthly increment, or yearly increment to highlight the carbon cycle in some of that same way that Dr. Podest was showing you. And you can save that animation right here and actually get some of the data. So worldview, we keep highlighting this because it's an incredible tool to access a lot of the NASA data sets. So I wanted to highlight that because making these animations isn't just for NASA folks. In fact, here is a tool that you can use to create your own animations. So please, take the time to zoom in on your area and make some different animations to explore questions, explore patterns, explore the carbon cycle as it's happening in your area. And again, you can change that increment that you are looking at from a daily, monthly, or yearly piece. And so we hope to see some creativity with this, because that is something that can be embedded in these presentations that you are making for the IVSS, or if you just want to share it with your local community, what's actually happening there. Okay, so that was not really what I wanted to highlight today, but that since we had a lot of interest in those animations and just how the satellite view can reveal the carbon cycle and some of these patterns, just really interesting. But what I wanted to kind of highlight today is, and Dorian Janney there was highlighting the value of these pictures. One thing that I think is important is that you can actually estimate biomass just by simply looking at a picture behind you, or in my case, behind me. And the key here is just how many trees are in that picture. How dense is that landscape? And so, just by taking your land cover observations or your tree height observations and looking at those pictures, you can actually get a good understanding of that above ground biomass piece that Dr. Perez was talking about. And in fact, when we look at our base map here, we can see these areas of high biomass. These are the green areas that show up on our globe visualization base map. And when I start looking at this, we can actually see the green areas, the high biomass down here in the Amazon. And you can zoom in and you can actually start to see some of those same patterns that Dr. Perez was showing in terms of how land is being used. But what I want to focus on is here I am, and you notice how green it is here. And I'm in an area that has a lot of high biomass. And importantly, what I want to highlight is that you can go in and get those land cover photos, for instance, and turn those on and actually start to get a sense for the different biomass that occurs in different areas. Right. And so if it's really green on these satellite images, kind of green, a dark green compared to this light green, that's actually just an indicator of high biomass. And you can see that when you look at any of these pictures where it's really dark green like that. And a component that we can see that tells us biomass is shadow. How shadowy is that? And that's related to the tree height. And so, just by looking at these pictures in these really green or kind of dark green areas that are on that satellite image, we can actually start to see how much biomass is there. Now, we can go out and measure it, but that takes a lot of time. And so that's where the remote sensing, even using your camera as a remote sensing sensor, gives us that ability to estimate biomass and to make that measurement. So it's really useful, like what Dorian was highlighting, to just spend some time in the globe visualization system looking at the green areas compared to the browner areas, and using these pictures to help you to understand that what you understand about biomass and that carbon cycle. It's all in those pictures. But we have NASA data. And so you can actually go and find in the NASA archives estimations, and you can zoom in on this map, and you can use this as a guide to where to look in the globe visualization system. And you can get some estimates for biomass, high biomass areas, low biomass areas. And you can, if you wanted to, actually access and download and work with this data right here. So you actually have access to estimations of biomass or carbon in your ecosystem. So connecting those up with those ground photos, the ground measurements are a great way to start connecting what you're doing to this important NASA science like that. So, we've got a lot of tools that we will help connect you with starting in January. And so a lot of what we're showing you right now are things that might get you interested, things to explore, areas to start looking at patterns. Why do we have these linear shapes? And some things like that you might want to explore for the IVSS. And so, this was kind of our big thing, connecting you with NASA biomass estimates and the science of carbon, together with what we're doing here on the GLOBE, with the GLOBE program and with those GLOBE tools. Now, remember, to do a full carbon estimation takes a lot of effort, a lot of measurements. And so that's one reason why the maps that we have are older. They tend to lag behind. And so this is where we can all actually contribute to the updating of this map, which was made for 2010, with our ground measurements. So that's where I'm going to leave it today. But we have a lot of exciting tools that we'll be presenting to help you do some science, to connect you with the NASA tools in actually helping to map, measure, and monitor this carbon cycle. There's a lot of interesting things out there, and NASA has their carbon monitoring system that is looking for data like this. So go out, make your observations, and contribute to us keeping track of what's happening with the carbon cycle.
Thank you, Peter. Does anybody have any questions for Peter? And I should note, this is such, what you're doing on here, Peter, is such a great thing, because it really focuses on what the 2021 IVSS is focused on, and that's data literacy. Because we've been in the middle of this COVID-19 pandemic globally, and a lot of people were on lockdown and weren't able to go out and take observations. So we really wanted to focus on how you can either look at the data you may have taken, or data from the GLOBE database in your location, or even somewhere else that you want to study, who knows? But you can actually go and understand that data by using tools that Peter has been discussing in all the past webinars, and including today. So this is a perfect way for us to get set up for what's going to happen in the second quarter of the campaign, as Peter mentioned, starting in January, where we're going to focus on that. How do you look at the data? How do you work with the data, visualize the data, for your student research projects? And we want to set this up so that it helps you out to the point where you feel super comfortable in looking at the data, because there's so many great tools out there. And that's why Peter is fine tuning, and filtering out the best ones for us to use, that we think that you would most benefit from, you and your students would most benefit from, for student research projects.
Perfect, Brian. Thank you for mentioning that, because that's exactly right. The data there's lots out there. And so our goal is to try to help you figure out what is actually useful. And I will highlight that in one of our last webinars, we put together a project where we were looking at mapping out trees using the high resolution imagery, similar to what Christopher was talking about earlier. And we actually have a project set up that uses the data that he presented today. And so I want to put that out as a teaser so that you guys will come back and actually learn how to use that new data, that high resolution data that Christopher talked about earlier. So we're trying to lure you back to some of our future webinars by teasing some of these tools and recognizing that you didn't learn it all today, and come back and learn some more.
And please also note that if you go to our campaign website, you're going to see a little link on the left side that mentions online tools and tutorials. And what we've done is we've pulled out the tutorial sections, online tool sections that Peter has been doing for the webinars over the past couple years. We pulled them out and put them into really specific sections on the page, so you don't have to filter through the whole webinar each time to get to Peter's presentation. We pulled those out. And there's some other ones as well. I did one, I think, on open altimetry and ISAT 2. But you can go and look at those individual, you know, anywhere from like 5 minutes up to like 15-minute videos about how to use the online tools. So those are good teasers too for when we get to talk more and more, you know, a little more in depth about these tools when we really get into the, you know, the meat of the student research and, you know, how you can use the tools to do this. All right. Anybody have any last minute questions or any discussion before we adjourn? I see there's lots of, you know, after every one of the presentations, everybody, you know, had to, you know, really like the information was being shared, and it's great. Several people said, Marilyn mentioned, you know, it's awesome and so helpful for the students. So there's lots of great stuff that we shared today.
I'm Bushra. I just want to comment from Pakistan that this is really a great opportunity for, me as a Pakistani, because the things that you people talk about, they are, though not new to us, but it's really a little challenging for us to apply in my context. And I would really love to, maybe it's not the relevant question here, but I would like to know that how best we can utilize this big data that we get either from the globe site or that my students they gather and so on. Yes, we can make graphs, we can make line or bar or other graphs, but what big picture we can utilize using this, that's really my challenge, and how best you can help me out in that. And moreover, honestly, it's really amazing to be there in this webinar since past many months, and have come up with so many new information, have met with so many amazing educators across the globes. And like the new terminology, I was a little confused. Maybe Mr. Nelson can address that. The first presenter, Dr. Podas. Yes, she shared about this that forest fires, they are a big source of tree degradation, forest degradation. So can we say that degradation through snow and through forest fire is the same? Because snow also causes forest degradation. So can we say, I just want to clear my concept, because I didn't feel like asking the question with her because she was overloaded with so many questions. So I restricted. So can you answer that?
I definitely will. Forest fires are how I got into remote sensing. It was because the forest that I was living in was on fire. And so the only way that we could look at the effects of that was through satellites and that remote sensing. And so part of what ends up happening when you have a fire is that it changes the soil, right? Some of that, the carbon in the soil can be burned up. And if it all gets burned up, then you have the possibility for floods and landslides and erosion, and bad things usually happen. And so that's sort of this connection between forest fires and rain or snow. And one of the things that we've been studying here in Oregon is that if you have a forest fire and you no longer have like a green canopy like this, the snow will actually melt off faster. And because everything's black, there's more sunlight that can reflect inside of there. And so that forest fires can actually cause the snow to leave the landscape 2 to 3 weeks earlier than if there was an intact canopy that was there. So that forest fire, can really change a lot of those dynamics. And so a thing that is important to do is 5 years after that fire is to go back once it's a little bit safer and to use some of the GLOBE protocols to actually measure the growth rate of some of the trees, how much carbon might be in the soil. And using some of these different GLOBE protocols, you can look at the after effects of these fires. And you can investigate, the intensity or the effects of these fires, even if they happened 5 or 10 years ago, which is usually when it's safe to go back there. So this is one of these things that we tracked the effects of fires back in, the fires that occurred in the 1970s and 1980s, and how the climate responded then. Now the recent fires, the vegetation that comes back is going to be growing in a different climate than what had grown before. And so we can't really predict some of these things. And that's where where just monitoring, tracking that tree growth tells us how water stressed the environment is, like Dr. Podest mentioned, or whether the area is actually sequestering carbon and continuing to grow, or whether it's not being efficient. It's not photosynthesizing as good as it could be because it's stressed in some way. And monitoring is the only way we really know with some of these things. So hopefully that answers the question.
Yes, you have. And okay, lots of other questions, but I'll put them in the GLOBE site, right?
Perfect. Yeah. And we have a lot of tools that we can help you contextualize this and localize this to Pakistan. And I think that's an important thing as well.
Yes, please help me in that. Because for instance, if I would talk about the same thing to my students about this, that trees are degraded by forest fires or through snow, etc. So they would ask that, Madam, the first question would be that, ma'am, tell us, do we have to plant the trees or we have to control the fires? Or so many questions there'll be there. So I really want to be clear first myself so that I can address their queries clearly and effectively. Yes, thank you so very much.
Yeah, those will be some nice challenging students. So we'd love to be able to answer any of those questions or help you with that. Probably similar ones to other ones that people are having, right?
Brian, you're muted.
Thank you. Yeah, so we're about 1 minute away from the end of the webinar. Does anybody have any last minute questions? All right, well, thank you everyone for attending the webinar today. This was great. We scheduled it for an hour and a half because we knew that we'd go over. We've done that the last like 3 or 4 webinars because there's so much great information that we can, bring to you, and lots of great questions too for the speakers. So that's what we want. We want the interaction, and we want people to really feel comfortable here asking questions, learning about the material, and then being able to take all what they learned and then bring it back to, the teachers back to their classroom, the students back to their study and research. So thank you all so much, and look out for tomorrow. I will send a link, an email showing, that we have the webinar recording up. So thank you all so much, and be safe, and see you next month.
Thank you. Take care.
Good to see
everyone.